Good morning, everybody. Welcome to a somewhat later edition of Weather Academy, of course, with Kathy Dahlkemper. She just finished her Wednesday briefing. She had a little earlier today, so of course we defer to her with some great information that we will have online. But it is Weather Academy time, and this is the last of our historical segments where we look back in time and look at some of the historical weather events. We've had a lot of them, and with the majority of you, of course, we have a lot of teachers, a lot of older adults we find who have been watching, but this is mainly for the kids. So decided to do my last two historical ones on a much more recent basis. In fact, we're only going to go back a few years, so except maybe for the very young who are watching, most of you in the elementary and middle school years should at least have an idea or perhaps remember some of these more modern historical events. And we're going to start right now. We're going to go back a little over 1 year. It was in April of 2019. Not here, well, we had our share of storms here in Erie County, but it was Crawford County that got hit with some of the largest hail that we have seen probably since the 1985 outbreak that we discussed last time. Here as we go full screen, this was, I don't know where in Crawford County, probably around the Conneautville, perhaps the Springboro area. Western Crawford County got hit the hardest. On April 14th, 2019, a 2.5-inch hailstone. Keeping in mind that the normal size of hail that hits here in Erie is about a 1/4 inch, which is maybe in between a ping pong ball and a pea. So to have something that large, and I searched and searched, I really thought I had some, pictures here, but I don't know where they went. They went into the computer abyss, but so many homes were damaged. When you get hail that large and it hits the side of a house, it hits a car, it's going to do some damage. Many of them looked like somebody had literally taken like a shotgun and just shot some right into the house there. Very frightening when you get that kind of hail. And usually with that kind of hail, what that means, if you want to come back, what that means is that there's a lot of turbulence in the air. When hail, the way hail forms, all raindrops are not the same inside a thunderstorm. Some are different sizes, and in the thunderstorm, even lighter, less intense thunderstorms, you have updrafts and you have downdrafts. So the updrafts blow the air and blow those areas, those raindrops up into the top of a cloud. Now, in the top of a thunderstorm, it's typically well below freezing and oftentimes will be near zero in smaller storms, and could be as low as 40 below zero in some of the larger thunderstorms. So when you blow the raindrops up into the top of that storm, they tend to freeze. Now, ice, because of its physical properties, is rather sticky. What do I mean? When water droplets form on ice, and when they collect on ice, they stick. They stay there, okay? The molecules literally kind of connect together as the water, the liquid, touches the ice. So it goes up into the cloud, freezes, so you have a little ball of ice. Then it goes down into the lower levels as an ice ball. Little raindrops collect on it, and then the next updraft blows it up. So you have the raindrop, you have the water around that raindrop, that freezes, then it goes back down, collects more water at the bottom of the storm, next updraft brings it up. So you kind of get this, this building of layers each time it goes up and down. Now this can happen a dozen times or more, and in the case where it gets this large, that's where you can get some pretty large hailstones. Usually it's just a couple times and then it gets blown out or gravity pulls it out. But in this particular case, this was a large hailstone. It also shows that there's a lot of instability, a lot of power, and that means that we have some damage. Here's some of the damage from tornadoes that hit Crawford County. These are courtesy of the Weather Service in Cleveland. We had some roof damage. We had the one that was covered a lot was the damage to the nursing home in Conneautville, roof collapse, and you can see we had what was called an EF2 tornado, a rather moderate intensity, and it caused some damage there to the house on the right. And if you look closely, you can see here the roof damage, and here a total collapse of part of that nursing home building. The roof completely blown off, windows blown in, and we have some damage here, windows to this house, and a lot of the shingles were blown off the roof. Typically, depending, it looks like the tornado actually hit the nursing home in the middle. And when a tornado hits you directly, you're bound to get some structural damage. Typically, as the winds get to 120 miles an hour, most homes can hold up from the wind. But if that tornado hits directly, you can get that kind of damage. So here's a look at the Doppler radar. Now, this isn't in Crawford County. This was actually, Crawford County wasn't the only area that got hit that day. We had a lot of western Pennsylvania and Ohio get hit. But the concept here is the same. The images on your left, that's what we call reflectivity. That shows the actual, how hard the rain is falling, or hail in this case. The heavier the rainfall, the greater the return. That's where you get the reds. But sometimes when you get, here it's a white core, oftentimes it's colored black when you watch our show. That's indicative of a very good reflection, and usually when you get it that good of a reflection, you have hail. So there's probably a core of hail here, and the next map, same area, but now we have what's called the velocity mode. And let's come back to me here, Cindy. Velocity mode means that it shows how the raindrops or hailstones are spinning inside the actual storm itself. And what it does, it measures the speed of rain or hail going toward the radar, and it measures the speed of other raindrops going away from the radar. So you have this kind of effect. What's going to happen in the middle? That's where you're going to get your spin. That's what makes the velocity mode so important. Let's go back to the map itself here. So what we have here on the right side, green is rain going toward the radar, and red is going away from the radar. So in between this area, this is an area where it's particularly strong going out, and here it's particularly strong going in. As meteorologists, we look for areas where the red and the green touch, especially if you have fast red and fast green. So this is the area where the spin of the atmosphere is strongest. Now, I don't have speeds on here, but usually when you get this kind of coloration, you have about 50 miles an hour going this way, 50 going the other way. What you do is you add them, and that comes out to about 100 mile an hour spin in the middle. And that's why when we look at that, if we see, spins going 100 miles an hour, that's when we figure that there could be some spinning and potential tornadoes. And it doesn't mean there's a tornado on the ground. This is a spin that's probably a couple thousand feet up, but it's a good first indicator of tornadic activity that can happen on the ground. So what's the weather map look? Do you notice a theme here? Now we've shown, this is like, I believe, the third different severe tornadic event. And most of the time we consider tornadoes going, forming along strong cold fronts like we have here. But what we've seen, this is the third straight time now where we had a stationary front near us with the storms moving along the front. And so we have the winds going west along the front while the air at the surface is going south, and that's what caused that general spin, and that's what caused the best part of the storm. Usually, here's a low pressure system, and normally areas to the north and east of the low pressure have the greatest instability. They have the greatest spin, and that's where you get the best chances for severe weather. So, you know, when we talked about, remember the Presque Isle tornado, we can come back to me soon. You talked about the tornado of Presque Isle. That was part of a warm front. We're talking about the tornadoes that hit Conyville. And you can tell, you know, we don't think of stationary fronts as, you know, particularly, you know, as tornado makers. But two of them, the Presque Isle tornado, actually three of them. The Presque Isle tornado, the one we showed last week in Mill Creek and Erie, that was on the stationary front. And in April of 2019, on the 14th, that was a stationary front. The only one that wasn't was the big outbreak in '85. That was the more traditional, you know, Midwest, you know, Wizard of Oz type of tornadoes that form from a strong cold front. So around here, so it's not unusual. You know, we here at the weather office, we don't just look at cold fronts, we also look at stationary fronts as potential rain and thunderstorm makers. In fact, the storms that we had this morning, if you were woken up to them, those were storms that formed along a stationary front boundary. And they indeed caused some small hail in the Edinburgh region, out toward Corey and into Crawford County. Small, almost ping pong size hail, nothing severe, but it did cause some rough weather farther east. In fact, I believe a watch has now been issued for the central part of the state, but that's well to our east. So that's what we look for back on April 14th. Also of note, April 14th, it wasn't just Crawford County. I said we here in Erie County also received some good storms. In fact, the highest wind gusts that I've ever seen here at the station, I've been here for almost 27 years, actually over 27 years. We hit a wind gust at our station of 81 miles an hour as a squall line moved on through. We didn't see any tornadic activity. There's probably straight line winds, but it's the closest thing to a tornado that I've seen in a while. There were a big rush of wind, that loud roar that you hear, and I'll tell you what, it was a scary experience, even though it lasted for all of 20 seconds. When you have an 80-mile-an-hour wind, you really have something. Fortunately, it didn't do too much damage to the station. And it was so localized that the airport only reported the wind gust, excuse me. Okay, that is what we call, what you heard there was just a test of the warning alarm. Those of you who have a weather radio, maybe your alarm went off as well. I thought, oh no, they issued more warnings here. Couldn't be the case. It's just a test of the warning alarm that the Weather Service does every Wednesday, typically around 11 o'clock. And it is around 11 o'clock right now. You never heard it before because we usually start around 10:30 and we're done before 11. All right, the next storm, the granddaddy of them all. If 1985 is the standard for summertime tornadoes around here, Christmas of 2017 is the standard for snowfall, lake effect snow. Now, we did talk about the storm of the century, and on a national scale, yeah, that one was big. But on a local scale, nothing comes close to Christmas of 2017. If you lived in Erie, even you kids, you know what it's like when that snow really starts to fly. Here's a typical picture of the snow and the blowing snow. We had about 36 inches of snow on Christmas, and that plus the blowing and drifting. This is, of course, a local baseball field. I believe I played on that field when I was younger. Imagine playing when you have almost, you had about 5-foot drifts here. And we had, that was just Christmas Day, we had well over 50 to 60 inches of snow in a 3-day period beginning late Christmas Eve and going through December 26th. And there, we showed pictures of this kind of lake effect that you see off of some of the more traditional, heavier lake effect areas, but not in our own front yard here in Erie, Pennsylvania. We just don't have that. Those of you in the snow belts might be a little more used to this, but for us here in Erie, This was something. This is the radar that, during the height of the storm. Now, this is colored in blue and different shades of blue in the wintertime. If this were colored like a normal summertime radar, you would probably have solid yellows and maybe even some red here in the Erie region. Dark blue is snow squall. And if we put, if this were a radar loop where we put it into motion, here's Erie, here's Edinburgh and Corey. Typically, winter, this band is down here along Route 6, but not on Christmas. It hugged the lake shore, and we had a west-southwest wind. Perfect wind direction. Lake effect, one of the biggest influencers of how much snow we get is how long that air stays over the water. So when you have a west-southwest flow, here's Sandusky, Toledo's probably out here. That wind goes from Toledo for almost 200 miles to Erie. And that is a long way for air to travel over the water. If you want to come back. So typically in lake effect events, wind directions shift from time to time. So the bands shift with the wind direction. So while some areas can get hit pretty hard, if they hold in the same direction, they may hold the same direction for anywhere from, say, 3 to 4 hours, all the way up to maybe up to 12 hours. And if they're up to 12 hours, that's when places like Edinburgh and Corey can get a couple feet of snow. This stayed in the same wind direction for almost 48 hours with very little change. So almost 2 straight days of the same kind of wind direction, this constant pounding of snow. Okay, now it did change a little bit, but it basically stayed in that general west-southwest direction, allowing for a continued, we call it fetch. Fetch is merely the amount of time that the air stays over the water, which it did, and just pounded the lakeshore with a lot of snowfall to the tune, again, of well over, total storm amounts were about 50 inches of snow. Now, we did have some controversy and a little bit on just how much snow we really received. The numbers were brought down after things were looked at, but for many of us, it was definitely by far the snowiest winter. Up until that point, the most snow we'd had was 27 inches. That was another storm system that Tom Atkins and I talked about, the very first one back in 1944. This one beat it, even with the adjusted amount, by almost 10 inches. So it was not even close. 2017 by far the biggest snow maker. Here's how the weather map looked that day. And it is a good setup for lake effect snow. Now I told you in the summertime that's the north, here's a low pressure, here's a low pressure. Again, we usually associate those areas with precipitation. That's what all this green is precipitation. Now, in the summer, we look to the east side of that low for the best lift. But in the wintertime, we go on what we call the back side of the low. That's where we get the cold air, and that's where the wind direction is affected on the back side of the low. So this low was set up, again, in a remarkably similar situation for a long time. What happened? This low moved out. This one in the Great Lakes went almost in the exact same place. So we had a case where both low pressure systems kept the wind direction the same. And in the upper levels, if you look, this right here, if you look at these lines, see how this line, we call it a kink, kind of bows here. That's what we call a trough. And that trough is basically low pressure in the higher levels. And when you have a low pressure at the higher levels, it can aid, if you want to come back, it can aid the low pressure at the surface and aid in lifting that air up to give us even more lake effect snow. We call it the perfect storm. You may have seen the movie The Perfect Storm. Same thing, where once in a great while, maybe 100 years, you get the ingredients that come together perfectly to give that perfect storm. We saw it in the storm of the century that hit the East Coast here. We saw it with, to some extent here locally, with the tornado outbreak of 1985. And then we saw it Christmas of 2017, where we had surface lows in just the right place, an upper air trough, and a wind direction with the perfect wind direction to give us here in Erie the kind of snows that many of you in the snowbelt areas know that you get a lot more. So those are the two storms, the big tornadic and hail event of April 14th, 2019, and the big lake effect snow event right here in Erie in 2017. So that concludes the weather history here. It's been wonderful. I've really enjoyed working with you on this, on the Weather Academy. Craig Flint will be back on Friday, and then Craig will do 3 more segments next week to close out the Weather Academy for this school year. And Craig will have more on what the future will hold for Weather Academy. Many of you have asked if, perhaps, are you going to continue this? Right now, there are plans to do that. We're just trying to figure out what's the best way to go about doing that. Craig Flint, though, will definitely be the head person for that, but hopefully he'll invite Tom Atkins and myself on once in a while to give little cameo appearances because it's great. Outside of being on the air, one of my favorite things to do is to teach and to visit classrooms just like yours, whether it's in class or virtual. And hopefully you enjoyed some of the historical weather events that have taken place that we've talked about over the past several weeks. So remember, what inspires you? Make sure that you look into things that inspire you, because you're never too young to figure out what you want to do in life. So that concludes our Weather Academy for this Wednesday. Again, Craig will be back on Friday with more good weather stuff. Take care.